And thank you for joining us on this webinar for our next installment of the NOAA Innovators Series. We're very excited about this talk. I am Katie Rowley. I am in the NOAA Central Library. If you do have any issues with your sound or your audio or the screen, we recommend you close out and log back in. That usually solves any problems. If you have anything else, please place that in the chat panel. We are going to hold all questions until the end. You can place your questions in the question panels, and I will be reading those off. And with that, I'm going to turn it over to Derek Parks to introduce our speaker.
Thank you very much, Katie. This is Derek Parks with the NOAA Technology Partnerships Office, and we sponsor this Innovators Series as a way to get more information out to folks about the people who are innovating in NOAA, the projects that they're working on, and the great collaborations that people are working on across our labs and science centers. And today we have Steven Ruberg. Steve is the lead of the Observing Systems and Advanced Technology branch at our Great Lakes Environmental Research Laboratory up in Michigan. And so currently Steve is working on a number of different research topics. The first one, which he's going to discuss today, is the development of a real-time coastal observation network, also known as RECON, which consists of buoys and autonomous vehicles. Steve's going to tell us all about that today. And that is related to ecosystem understanding, harmful algal blooms and hypoxia issues up there on the Great Lakes. And in addition, Steve works on aircraft hyperspectral imaging, providing harmful algal bloom information to regional managers, and the exploration of mapping of submerged sinkhole systems, which sounds like an interesting topic for another session. But for right now, I'm going to turn it over to Steve Ruberg to give you all a presentation on the RECON network. Take it away, Steve.
Thanks, Derek. I would like to talk about the sinkholes sometime. That's a fascinating topic as well. But today I'm going to talk about, as Derek said, real-time coastal observation network. We began development of this really connected to a visit to Woods Hole Oceanographic Institute in about the year 2000 or something like that. And a lot of the technology that is used at Martha's Vineyard Coastal Observatory, developed by Tom Austin and others at Woods Hole, we took advantage of their research on this and have moved it into further development. So I'll talk about the RECON system. I'll introduce a little bit about the Great Lakes and which is related to some of the things we're monitoring, and then where we're going to go in regard to winter observations or in understanding winter ecosystems. So the first image. Okay, my down arrow is not. Yeah, I'm not sure. Oh, there we go. Okay. Now you should be looking, and I'll just check in. I won't do this for every slide, Derek, but you should be looking now at the lower 48 states and the map of North America from NASA JPL.
Yes, sir. You are working properly.
Okay, sounds like things are working. All right, so this is just a gorgeous mosaic that NASA created based on the MODIS satellite, the Terra version of that, and then the space shuttle topography. And it's a mosaic of 500 images, but staring at kind of the center of that, you see the Great Lakes. And we have numbers for this, and sometimes I present this as the length of the coastline and all that kind of thing. But just kind of stare at that and think about those Great Lakes, just the U.S. side being stretched out along, for instance, the East Coast. What we like to let folks know that in the Great Lakes, this is really the longest coastline in the United States, with the exception of Alaska. So it's longer than the California coast. And if you added up the eastern seaboard plus the Gulf of Mexico, it's still slightly longer than that. So we, as a lab, that then is a challenge, of course, in monitoring this and really providing good observations, being the small lab that we are. But I think we're doing a great job. So then zeroing in on the Great Lakes in the center of that picture, just want to, get you familiarized with what they're all about. I mean, one of the things you notice right away is in the shallow sort of areas, In the lower part of that is Lake Erie. The water's a little greener down there, and then the northern lakes, the water's a lot bluer where they're more oligotrophic. Just some facts about the Great Lakes. No, really, a third of all U.S. boaters are registered in the Great Lakes. Michigan alone vies with California for the largest number of boaters, not boaters, in the nation. So registered boaters that are out there, sometimes on small inland lakes, but also out on the Great Lakes as well. Commercial shipping, that's not a big number for commercial shipping, but just kind of note in the upper left hand of the screen, Duluth, Minnesota, saltwater freighters can get all the way in that far into the country. Decent sport fishery, which is non-native salmon that were brought in to take care of non-native invasive fish that came in as far back as the Erie Canal. 40 million people drink the water, and it is 20% of the Earth's surface fresh water, so not groundwater, and not what's locked up in ice, surface available fresh water. Lots of fresh water in these systems, of course. And also with those freighters coming in, we do have invasive mussels and other invasive critters that are coming in that are really changing the ecosystem, which is motivating, of course, long-term monitoring as well. One of the things about the Great Lakes that you'll notice is that when we get really cold systems that come down from the Arctic, we then, with that warmer water, we then get things like lake effect snow, but that is also, of course, a source of evaporation. So the water leaving the basin is then can be transported out. Right now, the water entering the basin through rainfall, we've had some very high rainfall years in the last several years. That rainfall is exceeding that evaporation, and lake levels are going up, which leads to some serious problems. And this is a very recent picture of a house falling into Lake Michigan, and it's kind of a microcosm of what might happen under. Not a microcosm. It's actually, being the long coastline that it is. It could, if the lake levels keep going up, we could be seeing what we might see along the coastal areas and things like that in the future. But it's happening here now. Okay, and then ice. So lake levels are a product. One of the products that we work on. We do the research for that. The Corps of Engineers does the operational product. Ice cover is an area that we monitor, both our Coast Watch website as well as research projects that try to forecast what the ice cover might be. That's used by commercial shipping. It's used by Coast Guard for ice breaking. The Coast Guard essentially is using our Coast Guard is using our Coast Watch node website in the Great Lakes for a lot of their mission planning for ice breaking. If you look at some of the narrow choke points and that sort of thing, they have to keep those open. Once you get into the shipping season in March, those have to be reopened. And then they keep some of the lower lakes open throughout the year for delivering certain important materials like coal or things like that, or fuel oil and things like that. So then that same Great Lakes kind of put on a little bit of a chart. The brown area in the background is the basin. So again, when referring back to that evaporation image, when that evaporation leaves that basin, it actually then has the ability to, over a long period of time, lower the lake levels. But what I'm showing this particular map for is to show the map for the real-time coastal observation network. This is not the map that covers all observations in the Great Lakes. These are just the ones that we're responsible to. We have about 20. We're going to be going to about 22 because of a project that we're working on to get winter observations. So it is, the Recon network is classified as a NOAA Critical Observing System of Record by the NOSC, the NOAA Observing Systems Council. What we learned from Woods Hole was that we wanted to develop embedded Linux platforms so that we could really run kind of a offshore network. And so being tied to the network, we're able to sort of amp things up occasionally, do these refreshes where we're able to get more bandwidth. And that allows us to do some creative and interesting things on Lake Michigan. Well, actually, no, let me talk more about the observations. Those purple observation indicators are eddy covariance stations that we're beginning to use for lake evaporation. Again, trying to estimate what the lake levels might do in regard to evaporation is important, but also at some point, hopefully getting a handle on how to forecast lake effect snow events, which can be pretty impactful to areas like Buffalo or the whole, really anywhere downwind of Lake Michigan on the west side of Michigan. But also Cleveland and many other cities as well. And one we leave out in northern Michigan is Houghton, Michigan, which gets sometimes as much as 300 inches of snow a year. They just deal with it. It seems like we go into crisis mode for the larger cities. So then the MET stations in blue were really what we started with. That project led to transitioning that technology to the Weather Service. And the Weather Service, our regional Weather Service folks, repeated that technology all over the Great Lakes, and we quadrupled the observations. And I'm not sure where we are now with that, whether we've gone beyond that. I know we have, but I'm not sure what the number is at this point. But that was one of our transition projects. The Cleveland buoy we no longer operate in the lower right-hand side of the screen there. That one is operated by the Great Lakes Observing System now in a relationship with the Cleveland water intake. So we transitioned that buoy into operations. That's our hypoxia monitoring buoy. Now I'm going to talk about some project one that's on Lake Michigan that started actually with our sister lab, AOML, and then we moved it into Lake Michigan. So the buoys, now I'm going to talk about Lake Michigan buoy, and then I'll talk about some buoys that are on Lake Erie. Wish I could talk about all of them, but there's no time to really do that, I don't think, in a consolidated talk. So real-time observations from a buoy, as I just showed, one of the products that we provide data through is our own internal website, and it's just a way to look at real-time data. If you were to go further into it, you can see plots from 7 days or 2 months or a whole year or something like that. But the data that's displayed here is real time. The real time data goes to the National Data Buoy Center, the Met Ocean stuff, and then also some of the ecosystem parameters. A lot of the buoys, all of the observations for the buoys on Western Lake Erie go to GLOS, the Great Lakes Observing System, the IUS Great Lakes Observing System Regional Association, and those get translated into products that drinking water intake managers use. So here we go off into some of the data. Well, actually, no, I want to talk a little bit about while I'm the spokesperson here and talking about the project, lots of folks work on this with not only with internal NOAA folks or federal folks, but also Cooperative Institute folks through our Cooperative Institute for Great Lakes Research. And then Cherokee Nation, we have a couple of contracts through Cherokee Nation. And then Aerial Associates does some of our harmful algal bloom flyover stuff that we do, that Andrea Vanderwood leads. So ecosystem observations, fisheries acoustics and video. We originally deployed this system in the Florida Keys. That's in the upper left. I think I can actually use my mouse to indicate some things. I'll just kind of circle it there. That's not a Great Lakes fish, that's a barracuda. We deployed a system that would scan across the reef and acoustically identify in the red circle there, identify targets, in this case a large target. And then the image below that is the actual target that was identified, the video side of it. So that system has both video and a biosonics fisheries acoustics. So then when we put it in the Great Lakes, we mounted it a little differently. That system was mounted sort of looking horizontally. The previous system on a reef in the Florida Keys. This one is deployed in Lake Michigan to kind of get the seasonal migration of fish as they move from offshore to nearshore and then back. And what you can see on there is that in the orange is sort of what we call a recon hub, which has an Ethernet connection at the center of it, and then multiple ports that we can bring in, like the Ethernet connection for the fisheries acoustics, and then serial data connection for the acoustic Doppler current profiler that you can see there on top. And then a buoy, there really is not a typical recon buoy. There are about 3 different sizes, but a recon buoy in the lower left of the screen there. And that, again, is providing us fisheries acoustics information and video information. Now, looking at mussels, which don't move too fast, but there is some information we can gather on that from their feeding behavior or about their feeding behavior and so on. So then back to this picture of the Great Lakes, we're going to focus on Lake Erie there in the red ellipse, and I'm thinking, Derek, you're going to give me feedback if anything's going wrong here. It sounds like if I hear silence, I'm going to assume that we're going okay. Things going all right?
It's perfect. Thanks, Steve.
All right. Thanks, Derek. Okay, so and then back to this, Lake Erie is one of the what we refer to as the lower lakes. Cleveland, the city of Cleveland is on there. You can kind of see that about around the center of Lake Erie on the south shore, and then Toledo would be on the far western side of that. And then here's just zooming in on Lake Erie, a 2015 image that shows a very large, extensive microcystis bloom, cyanotoxin, or that it has cyanotoxin in it, that extends all the way north of Cleveland, but is really primarily focused, the intensity of it is focused in the western part near the city of Toledo. In 2014, that actually was a huge problem in shutting down the water intake. And just some zoomed in pictures, either from Andrea Vanderwood's aerial overflights of the city of Toledo, the river that flows through there, and then some nearshore areas, and then again that flyover. So 2014, August 3rd, a report from the Toledo Glade, drinking water for the city of Toledo, 500,000 people, was shut down due to the detection of toxins that exceeded the World Health Organization standards for the toxin microcystin. And so we had been working on this problem previous to that, and then it really amped up the intensity of the work that we do. I'm going to talk a little bit about the nutrient observations that we provide in response to that. So as a result of this, there was a U.S.-Canada binational plan that called for a 40% reduction in nutrients. The nutrients primarily come in through the Maumee River, which is in the far western part of the basin. And so in addition to those nutrient observations from buoys, NOAA provides Rick Stump and now through co-ops a weekly bulletin, sometimes twice a week bulletin, depending on the severity of the bloom. GLERL internally has developed something called the HAB tracker, which is also going into operations. And you can kind of see that there. It's really the static bulletin now turned into an online system that can look out 5 days ahead and kind of see what the bloom is doing. Lots of folks use this, not only just water intake managers. Of course, it's critically important to them to know if it's going to move into their intake, and the intakes are all over the western basin. They're all over the Great Lakes, but the western basin is impacted here. But also fishermen are actually looking at this and saying, okay, well, now I know where I can go to avoid the green, scummy water that if they're a commercial fisherman or a charter captain, they're going to want to be in areas where their customers aren't going to be kind of worried about that really intensively green bloom. So those products serve that purpose. The buoys then serve to support that, as well as provide other direct information to water intake managers. So just down on the bottom, some of the observations, I won't talk about all of those. I'll just talk about buoys and then some of the aircraft observations. The Western Lake Erie Nutrient Monitoring System, again, that 40% reduction that we're looking at. Four of the four actual nutrient buoys are located in the top part of the chart there. The bottom one is really more of what we're working towards to provide year-round observations in a place where we can get lots of power so we can operate other systems and instrumentation, which I'll talk about. But excuse me, those four buoys have what used to be Wet Labs is now Seabird phosphate sensor, what used to be Satlantic and is now Seabird Suna nitrate sensor, and then above is a YSI multi-parameter sonde, which gives us our phycocyanin, which is in chlorophyll observations, to give us some sort of immediate information about blooms. And so real-time information from the buoy, not that you need real-time nutrient observations, but you do need high-resolution observations. In this case, what this has been really valuable for has been the nutrient sensors, the phosphate sensor in particular, was somewhat problematic in this environment. It's a very turbid environment. And so we were able to do a lot of troubleshooting because we had the real-time data. But the high-resolution data, looking at the screen on the right there, I guess I can use my mouse for this, the blue is our individual observations, hourly observations from the buoy. The black line is just an average through that. The red line, the red dots really, are every other week or weekly sampling observations. And so you can see that the phosphate observations from the lab are a bit lower on average. The sensor overestimates a little bit, but they correlate very well actually. When you really dig in there and look at point by point, there's a really good correlation. The sensor works very well. And having those high resolution observations, you see early in the season, our monitoring efforts, our weekly monitoring efforts, the red dots again, going out there and collecting samples, we're missing some of the bigger phosphorus events that are really influencing the system. And in the lower part is just some of the responses of the system. So the chlorophyll sensor is providing us observations that where we get the big nutrient events and then the chlorophyll responds, but not always. Sometimes these things, the microcystis itself sort of repackages itself later in the year, and the sensors no longer work as well. As you can see that event that's around August, just after August the 9th there. There was a big event based on lab values, but the sensor itself didn't do all that well. And again, the packaging effect of these, the way these cells clump together at that point in the year. So really what we're getting out of this also is that not only are we getting nutrients from the river at this station, this one's right outside of the Maumee River, but we're also getting those events that happen due to wind-driven resuspension, and we're seeing that can have a significant impact to the phosphate introduction into the Western Basin. So part of the project is to tease that out and see what's having the most impact. Right now, river plumes still, but we're trying to understand those wind-driven resuspension events better. So also in Western Lake Erie at the Toledo water intake, what we've been able to do is run a cable down through that system. There's an internal part of it, and the doors to the water intake, come out the bottom. And so what we did was we mounted a bottom-mounted profiler, and we sampled about 6 times per day with that wide variety of instruments that were on there. What we then do is what we then did, and we did this for a couple of years, and we're still doing it, unplug that profiler and then plug in an acoustic Doppler current profiler for the winter. So we began getting a couple of years ago winter observations using these short cabled systems. But in this case, I'm going to talk about this profiler a little bit, particularly the chlorophyll part of it. Looking at the image now, if you look at the purple line here, the taller excursions, that is a significant wave height from a model. Oops, didn't want to go that fast. And you see that's in feet, and there was a reason for that. We were giving this talk to a mix of water intake managers as well as constituents in the region. So we wanted to keep it a little more understandable for them. And another thing to note is the instrument was giving us at that point in time a chlorophyll output. We really are now into just chlorophyll units because this doesn't necessarily represent total chlorophyll. But okay, so let's focus on at times when we have low wave heights at the beginning of the year. If you're seeing my mouse, there is a peak there. What that means is the peak is not only saying it's saying the chlorophyll is higher in those peak areas when the winds are lower. What you're usually seeing, and if you go to the far right of the screen and see that really big peak during very calm periods, the microcystis, in this case, is what it was verified as, is sinking to the bottom during those calm periods. It used to be in the HAB bulletin that we put out that we would make a statement such as, it's a very calm period, and so the microcystis has floated to the top, and it's probably okay for water intakes to bring that water in. But really what's happening is in those calm periods, the microcystis is sinking to the bottom. It's on the surface, as we can see from the satellite and we can see from this image. There's some scummy areas there. what's happening is there's just a thin layer on the top, and really, if you looked at those bins from the profiler, it really doesn't. The sensor doesn't see any high chlorophylls until you get really right to the surface. So we were then able to change things and say, look, the better time to pump water in is actually during wind events when things are mixed top to bottom, and then you have a lower overall chlorophyll, likely meaning you have lower overall toxin in the water. Okay, so talking about hyperspectral imagery, we've begun using in 2015 a hyperspectral system, and what I mean by hyperspectral is that it has high resolution bands from 400 to 900 nanometers. And we have 240 bands. Typical satellite like MODIS has about 6 or 7 usable bands. It has more bands than that, but usable for observations of harmful algal blooms. And then we're moving to a better camera that has even more bands and channels. And so what we're able to do with that then is begin to think about how we might discriminate among blooms and determine what is a diatom type of algae or what is Microcystis, a cyanobacteria. So that's work that's ongoing right now. So then what we do is we fly over areas like water intakes where sometimes near shore, sometimes the water intakes are so near shore that the satellite image, you really can't get an idea of what's happening there. So here we're able to fly directly over them, and we provide this product to Ohio EPA and drinking water managers in general. So that's a weekly report. So then I'm getting to a point where I'm going to combine a lot of these things here. We've also begun looking at autonomous systems, wave gliders, and of course, I think most folks are aware of the recent initiatives that have been put out by Admiral Gallaudet, and so we've been using wave gliders and a Slocum glider. I'm not going to talk about those. I'll talk about the work we've done with Monterey Bay Aquarium Research Institute with their long-range AUV, and then a potential surface vessel that we're going to be looking at called the Sea-Track. So we, in the image on the left from last August, we were able to run some track lines with the Tethys vehicle, one of MBARI's, Monterey Bay Aquarium Research Institute's long-range vehicles. And what's superimposed here are those track lines in and out of the bloom that Rick Stump's NCOS group creates and that is operational now under co-ops. We downloaded that. We're able to run across areas. The black area is where the Detroit River plume is coming in, which doesn't have a lot of cyanodes in it. But then the yellow to orange areas are areas where we know that the Microcystis is blooming and probably has higher toxicity. But now the image on the right is the chlorophyll observations from the Tethys vehicle. And so we see in the far right, we have lower chlorophyll levels that are out in that river plume from the Detroit River, and then higher as we go into shore, which is correlating really well with the satellite observations. We then flew over that with a hyperspectral system, and we got similar data as well. There's a forthcoming paper on that sort of geo-reference type of data. So then the problem though with the Tethys vehicle is it was designed for open ocean stuff, and we're talking about levels or depths in the Western Basin. It's sometimes very interesting if we could get into 1 to 2 meters. We limited the vehicle's operation to 5 meters, and even though we did that, we still hit the bottom. So we see a little bit of mud there in the water. We had to go rescue it after it got a little less than neutrally buoyant, let's just say that. So what we'd like to do then is move that 3G system that is out there collecting toxin information, chlorophyll information. The 3G, if you don't know, is those cartridges in the lower right, that little lower right picture, can pull in samples for DNA analysis. It can lyse the cells and send them off to a toxin sensor, which can give us an indication of what the levels of microcystin are. That is totally in development right now, and we're under the NOAA Omics the OAR Omics program and other projects, local Great Lakes Restoration Initiative funded projects. We're working on that system. Just some facts on the vehicle that we want to mount the 3G system into. We're hoping to get that through a PCM HAB RFP that we applied for, but if we don't get that, then we actually have some other ideas on how to get that funded. Okay, Okay, so what I want to do, the reason that I mentioned the short cabled systems and the reason that I mentioned AUVs and that sort of thing is that there is a real lack of winter ecosystem observations in the Great Lakes. We put our boats up in November. Even our steel hulled boat is not really adequate to plow through something like you're seeing here, this pancake ice that you're looking at. And so what we would like to do is think in terms of autonomous underwater vehicles that could operate for long periods, perhaps the MBARI long-range AUV, or perhaps this Saab Sabertooth AUV. And what we would like to do then is have them located on a short cabled system that can provide lots of power and move into a docking station, plug in, download data, recharge batteries, and go back out. So that's a very real thing that we're entertaining. We have funding that could contribute towards this. We're trying to find other sources of funding so we can actually do it. So just summarizing in general, what I've talked about is that the observations that we're using are being applied to Great Lakes model and forecast development and our ecosystem understanding. And I should also add that, a very real part of this is water intake managers using those Western Lake Erie buoys, the region in general, looking at those nutrients and trying to understand how we can control nutrients, and then how will we know that they're controlled out in the open lake, given that that resuspension events may be carrying on the nutrient problem for longer. All the observations are made available regionally, being NOAA. Once we run everything through Quartod and all of that, we make it available to the public. And we see that a lot of recreational folks use observations across the basin, but then there are a lot of commercial applications, like for commercial shipping and that sort of thing, where they've begun using our systems. This short cabled systems and AUV integration offers hope for winter ecosystem observations. And I would say that if folks want to talk about testing winter systems, under ice systems that might be used in the polar regions, perhaps the Great Lakes might be a way to test those out. There are a couple of places to do that we have as the Great Lakes Environmental Research Lab, but there's also a lab at Michigan Tech University that is doing some work in regards to this as well. So that could be accessed through our Cooperative Institute. Okay, that is all. Just some of our collaborators, the hyperstructural stuff, we collaborated with NASA on that. Of course, the Great Lakes Observing System, Michigan Tech, and the Great Lakes Restoration Initiative has funded most of this. I won't say most, but a majority of this work. And GLERL Base has funded a lot of it as well. So anyway, happy to work with our partners at EPA and MBARI and that sort of thing too. So that is it. Are there any questions?
Well, thank you very much, Steve. While people are busily typing in their questions, I will kick things off with a couple on my end, and then we can have Katie read off to us what's come in from the group. One thing I was curious about, you may or may not know the answer, but have you heard any anecdotal or real figures for how much money has been saved as a result of operationalizing some of these HAB monitoring stations into operational products that they're using for their water quality? I mean, just in terms of cost savings, if nothing else, or have you heard anything from commercial fishermen, any other users of the system?
Good question, but I know that those studies are happening, and in some cases they have happened. The water intake managers will tell you that just having the situation awareness and being able to control the timing of when they're going to begin using certain things to eliminate, or to reduce the impact of blooms and that sort of thing. Actually eliminate, in all intents and purposes, they've gotten to that point with their technology. They very much appreciate any of the observations at a certain, and so the question is, in answer to your question, let me just be right up front. I'm not prepared today to offer that, but for a long time we thought we were giving them too much information, the water intake managers. But recently that we've begun to understand, they're scientists too. They do water science, and they just are eating up anything we can give them, providing, I'll call it situation awareness, having a Navy work in my background, and they just really appreciate anything they can find out about the system. But yeah, no answer on the question about the cost savings. They have said they are, and I know folks are looking at that. So
great, and that kind of leads. Your earlier answer leads to my second question, which is on the winter ecosystem analysis. Is that something where you're trying to address specific problems, or is this more for general ecosystem awareness to know what is happening during the winter months with the system itself and how that might impact summer? Or is there a specific problem with water quality and other issues during the winter as well?
And again, it's another case where the observations that we use are welcomed by the water intake managers, because you do get some pretty severe sediment resuspension events, and you're not going to see them by satellite if you're under a lot of cloud cover, which we are in the wintertime in the Great Lakes. Winter observations. I guess I'll start out by saying that of anybody in the Great Lakes, we probably have a larger history of winter observations, and by that I mean putting out instruments that are battery operated and maybe observing parameters such as temperature or chlorophyll or something like that, or acoustic Doppler current profilers that are measuring waves and currents and things like that, and recently ice thickness. What we haven't been able to do is integrate that into a system that can tell us about the ecosystem. So you asked about problems that could be addressed by real-time systems. Again, the water intake managers want that situation awareness even through the winter. It might be something as simple as turbidity, but we do occasionally get under ice blooms in certain areas, and really we're not even 100% sure where those areas are necessarily, because nobody's out there monitoring. We just know, based on a little bit of work that the Canadians have done on Lake Erie, the overall system, where I see it going, is we have observations that are giving us ice thickness observations. We can then correlate that with some ground truthing, so that we can get a better capability for forecasting ice thicknesses and things like that in various regions. Again, that goes to commercial shipping, Coast Guard ice breaking. Some of the real-time systems are also have simple as webcams that we're correlating with our synthetic aperture radar ice classification, and just to kind of make sure that we're classifying the ice types properly. If you can tell the Coast Guard how to avoid the brash ice, which is really those big stacks and piles of ice and that sort of thing, they can do a lot better job of breaking the ice more efficiently and better for commercial shipping. So.
Interesting. Okay. Well, I'm going to stop hogging the airwaves and let Katie take over with the audience questions.
Great.
Thanks
Thank
for
you, Derek. We do have a couple questions. First up, can you please share what frequencies you are using for the fisheries acoustics? Are you doing species identification based on the TS?
We are using 70 kilohertz, 70, and oh boy. And I included Doran Mason as one of the folks on that. 70, and pretty sure it's 70 and 120 kilohertz. It's been a while since I've looked at that. I think it's 70 and 120 kilohertz. And were we doing species identification with that? No. Mm-hmm. What we were trying to do with the system in the Florida Keys was just kind of do a large target, probably this, smaller targets, probably schools of fish. So a general identification of, based on size, but we weren't doing anything real specific with the acoustics. Obviously, with the side-by-side video, you're able to then say, yeah, that's a barracuda. But we didn't really get too far down the road on that in looking at maybe something like differences in swim bladder, returns and that sort of thing, to be able to tell what type of fish it might be, if that's where you're going with that.
Okay, thank you. Next question. Do you have plans to more deeply incorporate the use of unmanned aerial systems into this observation network?
We have recently attempted to purchase a OMAO Air Operations Center approved purchase, I should say, because we didn't do it on our own. You can't do that in NOAA, which is good. We just completed the purchase or all the acquisition materials for a DJI M600, which is a big one, so that we can operate that and get some areas nearer to shore that we're kind of missing with the aircraft and that sort of thing. But that was tied up in the coronavirus shutdown in China, and then it may be a while before we get that. But the plans are to integrate the smaller of the two hyperspectral cameras into that. Those are Rezon products, and they've already done that with this very same M600 vehicle. So we'll be in good shape if we ever get it in, and if other things don't change in relation to use of Chinese-made vehicles by the United States government.
Gotcha. Is there plans for unmanned marine systems? I know you were talking about using them, but do you guys have plans on purchasing or incorporating more of that?
Yeah, and so unmanned marine systems, we have a couple of wave gliders that actually I'll give credit to the National Data Buoy Center. They didn't want them anymore, and we will be using them this summer for primary productivity observations on Lake Michigan. And then we are working with our cooperative institute with a wave glider that is really helping us continue the development of our three-dimensional temperature models and biophysical models that relate to chlorophyll in the deep chlorophyll layer and things like that. So those two are sort of the workhorses at this point in time. What I tried to communicate there in the last slide is that really the way we're going to be able to get the most cost-efficient way that we're going to be able to get those under ice winter ecology observations, I believe, would be through autonomous systems. We may risk a glider at some point. We didn't have a severe winter this year in many recent winters, 2014-15 being the exception. We have had situations where the middle part of the lakes has been pretty open. So we could probably run a glider during the winter that would provide, those basic observations that they provide. What I'd also like to do is get some sort of a vehicle that can be recharged, repowered at a docking station, dump its data, and then go back out and collect more data. I think that's probably going to be the better way, rather than building a big ice-hardened vessel, which that would be helpful too, to do the ground truth, but there would only be one of those in the Great Lakes then. I would like to see us go towards a autonomous underwater vehicle that can operate under the ice. And I know the Arctic regions are really working towards something like that as well as the United States Navy. So
Great.
that's the plan that's in my head is trying to get these things going. And we actually have some funding where we're trying to get at least a demo going on that next year.
Great. Okay. We have another question. What is the best way that citizen scientists can help with monitoring?
Well, in the Great Lakes Observing System Regional Association, Kelly Page at GLOS is doing a good job of beginning to get citizen scientists involved using cell phones and things like that to sort of confirm where harmful algal blooms might be and things like that. But at this point, we have not, as a lab and using those observations, we have not begun using any of that. So yeah, I mean, there's always a problem, and when you're building models and then attempting to build that next forecast that's going to get transitioned into operations, there's always a problem in getting that data stream set up. And I think citizen science shows a lot of promise in confirming or validating some of our observations, but at this point, we're not using those.
Great. Okay. Last question. Can the attendees download a copy of this presentation? Would you be willing to share this?
There is one slide that we haven't published, so I would be happy to. Where would they be downloading it from, Katie?
They could email the library, library.brownbag@noaa.gov, and we could supply them with a copy of the presentation PDF if you would like to tinker with it a little bit first and send us a copy. that would be great.
Yeah. Yep. Let me get there's one slide in there that, we want to publish on that, and I'd rather, I think the co-authors would appreciate it if I would take that one out. So, yeah.
No
Okay.
problem, no problem. That seems to be the end of our online questions. Derek, did you have anything else?
I do not at this point, but Steve, I'd like to get you back at some point and talk about a few of these other components and some of the other things you're working on.
Yeah.
So
Yeah, happy to do it. And I think that the sinkhole stuff is I don't know. To me, it's very interesting. Maybe not everybody thinks sinkholes are interesting, but but yeah, any of these other topics, if you see something in there, feel free to give me a shout.
Well, thank you very much for taking the time and sharing everything with us. We definitely appreciate it. And thank you, Katie, as always, and the NOAA Library for helping us out with this seminar session. So I will leave it to you to close us out, Katie.
Okay, thank you everyone for joining us. This was recorded, so it will be up on the library's YouTube channel a little bit later. And we will see you all next time on the next Innovators series. Please look out for that email. Thank you, everyone.
Thanks.